Good evening all. So today we are going to start non-homogeneous second order differential equation. Okay, homogeneous we have finished. Non-homogeneous second order differential equation. Okay, so in this what I told you, the form of this will be d2y over dx square plus p dy by dx plus q into y will be equal to r. Okay, so here r is non-zero value. If r is 0, then it will become homogeneous differential equation. Okay, so directly we will go to the method how to solve such a type of problem. Method for calculation of y or method for solution. Okay, so number one, there are two in two form we will solve this equation. Solution will be, so first of all I will tell you here solution y is made up of two solutions y1 plus y2. This y1 is named as complementary function and this y2 is known as particular integral. So these things we have to note down. So this is complementary function and this is particular integral. Okay, so now how to find out this complementary function? First thing is this. So in this case, to find complementary function, put r equal to 0. Means this case we have done already, put r equal to 0. So then whatever the problem, whatever the solution is coming, that we have done in homogeneous case. So it is similar. So that will be known as complementary function, means it will be y1 only. Whatever y we found out in the homogeneous, so that will be working here as complementary function. This means to say, okay. Find solution y1, that is complementary function. So you have to put r equal to 0 and find solution of equation. Find solution of equation y1, that is complementary function. Okay, so here y1 is nothing but complementary function. So this you remember. Number B. Now write equation equation can be written in the form f d y is equal to r. Okay, so you can write this equation like this, and here f d is what? F d is this much. In place of d2 or dx square, we will write d square y plus pd y plus q. But y we have to remove from here, now then only it will be fd. So fd is this much. Okay, and here what you have taken, d is equal to d by dx and d square is equal to d square by dx square. Okay, so note down this much.
Sir.
Okay, so now what to do here to find out y2. So here y2 solution is your particular integral that will be equal to 1 by fd. You know that in the fd there are differential form only. So this is double derivative, this is single derivative. So 1 upon fd of r you have to do, and r is function of x here. Okay, r is already function of x, so you have to do 1 upon fd over this. So this will work as operator. It is operator, and this r is function of x. So operator is applied on function of x. Okay, so after that, if you find particular integral and complementary function, after that you will find answer will be complementary function plus particular integral. So only this much is the method. Okay, but here again it depends. What is this function? It depends upon the function of x. How it is? It is in terms of x square, x cube, like this, or it is exponential term, or it is sine cos, like this. So if this is like this, so then the solution will be different. Okay, so that also we have to learn. Number A, if r is suppose exponential term e to the power ax, then you will find particular integral will be equal to 1 upon fd e to the power ax. So whatever you can replace here, if such type of equation is there, so you can directly replace d by a. Okay, so in such case replace d by a. So then answer will be 1 upon fa. 1 upon fa, this is function of d, now it has become function of a into e to the power ax, but provided fa is non-zero. If it is non-zero, then only it is possible. If it is zero, then it will become infinity. So this is a bigger problem that we cannot accept. So it means fa should be non-zero. Then only we can do this. Okay. Now second type of case. Okay, one more thing. If suppose fa is zero, then what to do? If fa is equal to 0, so then what you have to do? So then particular integral will be 1 upon f dash a. You differentiate this with respect to d, then in that you put d equal to a. Understood? So then it will be f dash a. But here with the e to the power ax, you have to do one thing, you have to multiply with x. So then it is equal to that. Okay, if again it is also here also provided f dash a should be non-zero. Now again the question come, if f dash a is also 0, so then you have to go further, then particular integral will be 1 upon f double dash a. You have to double differentiate fd with respect to d, and here also you have to multiply with x square into e to the power ax. So like this process will go on till that you get the answer that your here also f double dash a should be non-zero. So condition is like that. So note down this.
Sir.
Okay. Now one more thing you can do: sine, cos, and hyperbolic can be written in the form of exponential and solved. So this also can be done. Okay, but sometimes it becomes lengthy. So direct formula also we can remember if sine cos is there. Okay. Otherwise, this is also the method. You can convert that into exponential term, and exponential method we have learned. Okay. So that also you can do, or direct also you can do. That will save your time. If suppose our right hand side is sine ax, so then your particular integral will be 1 upon fd into sine ax. Okay. So in that formula, actually this formula work only on d square. So that's why especially I am telling you that it will work on d square. Okay. So that's why I am writing here, deliberately I am writing here d square. Okay. So okay. So we can write here work only on d square and rest all same. Okay, method is same, your function is also same, but it will work only on d square. So I'm telling you. Okay, so we will use it, then you can easily find it. 1 second, let me take. Okay, so here what you have to do in that fd square, I know that is the same thing, d square plus pd plus something something. Okay, so in that whatever the d square term is there, so just that only you have to replace. It means that d square term you have to replace by minus a square, and it will be sine ax. Okay, so what we have done, d square replaced by minus a square. So that will be the method. Okay, again C part, if r is equal to cos ax, then particular integral will be 1 upon fd square cos ax. So in this also it is same, it is similar. Here also you have to put 1 upon f minus a square, and it will be cos ax. So whether it is sin ax, whether it is cos ax, so you have to just replace d square by minus a square. Note down it. Okay. Okay. So now till now we have seen that these are the single case. Okay. If suppose there is a multiplication of 2. So next case I am taking, if R is equal to multiplication of exponential term with some function of psi x. This psi x can be sin x, or it can be x square x cube, like this, with the exponential term. Okay, so then this also we can solve easily. So for that, particular integral will be, just you have to remember this procedure. Particular integral will be 1 upon fd e to the power ax psi x. Okay, so what we do, we cross this through this operator. So when we cross it through this operator, so it will give you the answer. The e to the power x will be unchanged, but here in place of d you have to write d plus a. It will become d plus a. If it is e to the power minus ax, then it will be d minus a. Okay, so that you have to do, and now it will be applied only on single. And on single, what it is, if it is cos x or sin x or x something, okay, so that you can apply accordingly method. Okay, now next method is, if r is equal to x to the power n in term of x, so then your particular integral will be one upon fd x to the power n. So whenever it is x to the power n, so what you have to do, this fd you have to make a arrangement for this fd so that it become the binomial expansion. Okay, so then it will be whatever is there, so it will work as fd to the power minus 1, and then you can expand it binomially, have a binomial expansion, and then you binomial expansion you apply on x to the power n, because this is fd. In the binomial expansion you will get the differentiation terms. Those differentiation term will be with power of 0, power of 1, power of 2, and they will differentiate this x to the power n accordingly. So like this we go. Okay, so now we can start the questions. There is a question. Force oscillator problem. Force oscillator problem. In force oscillator problem, it will be like this: d2y or dt square. We have discussed it already. Plus 6 dy by dt and plus 8y is equal to 42.5 cos 2t. Okay, so actually here it is working as external force. And this term is your restoring force, and this term is your damping force. We have discussed it earlier. Okay, and this is your normal force, F equal to ma. From there, this is the acceleration part. Okay, so note down this. Okay, so I want to write, first of all, I need what is FD. what is FD here? This will work as D square and plus 6 into D and plus 8. That will be my FD. Okay. Okay. So FD is this much. So now I have to find out. So solution will be y equal to y1 plus y2, or you can write complementary function plus particular integral. This will be the solution. So first, to find complementary function. So what you have to do? Auxiliary equation you have to find first. See, what I told you, in this case, to find CF, put R equal to 0. So then your equation will become FDY will be equal to 0. Okay. So this is a homogeneous equation. So to solve that, what you have to do? Auxiliary equation. Auxiliary equation you have to find. So that will be from here D replaced by M. So it will become M square plus 6M plus 8 equal to 0. Now you have to solve it and you have to find out the two roots because it is quadratic equation. So two roots, this is 8 1 8 and 6 plus what you can do, 4 plus 2, that also will be 8. So M square plus 4M plus 2M plus 8 equal to 0. This implies M you take common, M plus 4 plus 2 you take common, M plus 4, and that is equal to 0. And it will be M plus 4 into M plus 2 is equal to 0. So this implies M will be equal to minus 2 and minus 4. So these are the two roots. So complementary function will be y1 and that will be equal to, because these are two real and distinct roots. So answer will be C1 e to the power minus 2t plus C2 e to the power minus 4t. Okay. Any problem in this? So this is same like homogeneous. Now second question is how to find particular integral. So to find particular integral, your particular integral will be 1 upon FD into R. And what is R here? This 42.5 cos 2t, that is R. So it will be 1 upon FD is D square plus 6D plus 8 into R. R means 42.5 cos 2t. Okay. So note down it up to here.
Done, sir.
Okay. Now see, 42.5 is a constant into 1 by d square plus 6d plus 8 and cos 2t. So this is the question. So I already told you, if it is cos ax, sin ax like that, so what we do, just it will work only on d square. So here what you have to do, replace d square by minus a square. It means what? That is minus of a is what? 2. So minus of 4 you have to write in place of d square. So then it will be 42.5 into 1 by minus 4 plus 6d plus 8 cos 2t. Again it will be 8 minus 4 is 4. So it will become 6d plus 42.5 into 1 upon 6d plus 4 cos 2t. Now what to do next? what to do next? So this is a problem now, because we can apply the formula only on d square. So our trick is that you can make this d square. So this equation you can convert into d square. And how to do that? So method for that is, first of all, you this d, you make the coefficient of d 1. So how to make it? You just take 6 common from here. So it will be 42.5 divided by 6. Then it will be 1 by d plus 4 by 6. So 4 by 6 will be 2 by 3. And it is cos 2t. Now what you have to do here, to make it d square, what we do, we make a trick that you multiply in denominator and numerator by d minus 2 by 3. So 1 divided by d plus 2 by 3. I multiply here d minus 2 by 3 and divide by d minus 2 by 3 and cos 2t. So this we do everywhere if our function is not finished, our d function is not finished. Till then you have to do like this. So it is 42.5 by 6 into d minus 2 by 3 divide by. So now it will become d square minus 4 by 3. 4 by 9. D square minus 4 by 9 and cos 2t. Now in this, here in the denominator, now it is a d square, and on d square we can have the replacement, same replacement. So then it will become 42.5 by 6 into d minus 2 by 3 divide by, in place of d square you write minus 4 and minus 4 by 9 cos 2t. Okay, note down up to here. Done?
Yes, sir.
So here you can take LCM now. It will be 42.5 divided by 6 into 9 will be LCM. So it is minus 36 minus 4 minus 40, and 9 will go in numerator and divide by minus 40. Okay, so then actually this minus you can apply here. This minus you can multiply inside this. So d minus 2 by 3 cos 2t. So it will become 3 2 ja 6, 3 3 ja this. So 42.5 multiplied by 3 divided by 40, and it will become 2 by 3 minus d into cos 2t. So now cos 2t, now you can multiply inside. So it will become 42.5 into 3 divided by 40 into 2 by 3 cos 2t. Okay. And minus d, you can write d by dt cos 2t. So you can differentiate it. This value 42.5 into 3 divided by 40. So how much it will be? I'll write it like this. Now 2 by 3 cos 2t minus it will be sine 2 sine 2t with minus sign, so that will become plus. So here 3 also. What is this answer? Can anybody check with calculator? What is this value? $3.18 into 2 by 3 cos 2t. Hello?
Sir, we have a extra 2 in the denominator, sir.
Oh, sorry. Here now.
Yes, sir.
So it divide by 2. So then it will be 80. So 2 sine 2t. So answer will be, miss, again further I have to divide by 2. So answer will be 1.59. So answer will be in place of this you write 1.59. So this will be the your particular integral. Hence total solution y will be y1, and y1 is what? C1 e to the power minus 2t and plus C2 e to the power minus 4t. So this is your CF part, and plus particular integral, that is 1.59 2 by 3 cos 2t plus 2 sine 2t. So like this you have to find the complete answer. So in the exam it will be easy portion only, but for practice some hard portion we have done. Okay, note down this. Done? Yes, sir. One more question you can take. Solve d square plus 1 into y is equal to 5 e to the power minus t cos t. Okay, so here fd is what? D square plus 1. Now number 1, to find CF, auxiliary equation will be, in place of d you put m, it will be m square plus 1 will be equal to 0. So m square will be minus 1 and two roots are m equal to plus minus I. Okay, so here you can write it 0 plus minus I. So alpha is equal to 0 and beta value is equal to 1. So solution of this will be y1. Y1 is complementary function, and that will be a cos t e to the power, first of all, e to the power alpha. Alpha is 0 into t. A cos beta t. Beta is 1 into t plus b sin t. So answer is a cos t plus b sin t. So this is our number second, particular integral. That is main part here. So particular integral is 1 upon fd into r value. R is 5 e to the power minus t cos t. So 5 will come on left hand side directly. This is a constant. So 1 upon fd e to the power minus t cos t. I told you that if in the multiplication exponential term is there, so that can be crossed through this operator by placing d equal to d plus a. So here a is minus t, sorry, minus 1. So what you can do, it will be 5 into e to the power minus t into 1 upon f d minus a. Then cos t. So now what is fd? Fd is d square plus 1. So 5 into e to the power minus t divided by d square plus 1. So in place of d square plus 1, you have to write d minus 1 whole square plus 1 into cos t. So here actually it is d minus 1. D minus 1. So now we can solve it. Okay, so note down it quickly. Done.
Yes, sir.
Okay, so next what we can do, you can open it. Five e to the power minus t into 1 upon d square plus 1 minus 2d and plus 1 cos t. Now it will be 5 e to the power minus t 1 upon d square minus 2d plus 2. Okay, cos t. Now you can apply the formula of cos t. So that will work only on d square. So what you have to do, replace d square with minus a square. That is minus a square. What is a value here? 1. So minus 1 you have to put. So your particular integral will be 5 e to the power minus t into 1 upon minus 1 minus 2d plus 2 cos t. So this minus 1 plus 2 means it will be also minus 1. So minus 2d 5 e to the power minus t 1 divided by minus, you can take common here, it will be 2d plus 1 into cos t. Now again to solve it further, what I told, you have to make the coefficient of d 1. So 2 you can take common here. So it will be minus 5 by 2 e to the power minus t 1 by d plus half. And once it has become d plus half, what is my next step? I am taking here only. You just multiply t minus half and t minus half in numerator and denominator both, so that it again becomes the d square. So it will be minus 5 by 2 e to the power minus t 1 by, it will become d square minus 1 by 4, and in the numerator it will be d minus half, and it will be cos t. So again replace d square equal to minus 1, so that will be minus 5 by 2 e to the power minus t into d minus half cos t divided by minus 1 by 4. So note down this.
Sir, is it 2d minus 1, 2d plus 1 in the denominator part?
Here now it was minus, yes, we have done wrong. It was minus 1 and plus 2, so plus 1 it will be na. So minus, if you take common, then it will be d minus 2d minus 1. So everywhere you have to do. So it will be d minus half. So then you have to multiply by d plus half. So it will be d square minus 1 by 4 only, but here it will be affected. So please correct it. Thank you.
Sir, 1 minus 2d. Sir, 1 minus 2d.
No, minus I have taken common, no?
Okay. Okay, done.
Correct it. So now we can take it, because it is minus 1 by 4. So LCM will be 4. It will be 4 plus 1, 5. 4 will go in numerator and minus will become plus. So it will become 5 by 2 into 4 by 5. And d plus half I can write d into cos t and plus half into cos t. So just you can differentiate it directly. So this 5 to 5 cancel, 4 by 2 will be 2. So 2 into, this is just d by dt. Okay, you can differentiate it. It will become minus sin t and plus half cos t. So again here also you can take whether you leave it like this or you want to match in the option. Okay, so you can take LCM also, but no problem. Okay, hence y will be CF. CF is what? A cos t plus b sin t, and plus particular integral is 2 into minus sin t plus half of cos t. So like this you can solve this type of problem.
Sir, exponential term will be there or not? E to the power minus t.
Okay. Yes, it was there, no?
Sorry,
No, it is there. It is there. It is there. Correct it. Okay. Let me take now because one question I am taking for each method, so that it will not be problems to solve many problems. Solve d square minus 4d plus 4 into y is equal to 8x square into e to the power 2x into sine 2x. Okay, so this is a big deal now, because R is having x square also, exponential term also, sine term also. Okay, so but don't worry, this is a difficult one, but we will go through this, and easy question you can solve easily. Okay, so here, first of all, to find the complementary function, what you need to do, auxiliary equation. Auxiliary equation will be m square minus 4m plus 4 equal to 0. So it will be m square minus 2m plus 4 equal to 0. So here you can take m common, m minus 2 minus 2, m minus 2 equal to 0. So m equal to 2, 2. So this is repeating, real and repeating, or real and equal. So what you can do here, so complementary function will be your y1, that will be c1 plus c2x e to the power ax, a is 2, so e to the power 2x. Okay, now coming to particular integral part. So to find out particular integral, that will be 1 upon fd into r. R is lengthy here, but don't worry, and 1 upon d square minus 4d plus 4. Here r is 8x square into e to the power 2x into sine 2x. Now with the help of formula, we can get rid of this e to the power 2x, that we can pass through this operator. So e to the power 2x will come this side, then it will become d plus 2 whole square. In place of d, you write d plus a. A is 2 here, minus 4 d plus 2 and plus 4. Then it is remaining only 8x square into sine 2x. Okay, so e to the power 2x 1 upon, now you can open it, it will become d square plus 4 plus 2d. No, it will be 4d and minus 4d and minus 8 and plus 4, 8x square into sine 2x. Okay, so this 4d to 4d cancel, so it is d square only. Understood? So this will become e to the power 2x divided by 1 by d square, 8x square into sine 2x. Okay, so note down it first. Start from here. Okay, don't note down this also. Done?
Yes, sir.
Okay, so now tell me, what is the meaning of 1 by d square? Can anybody tell? Because d is the differentiation. So inverse of differentiation is integral. If it is one time differentiation, it is one time integral. And 1 by d square will be double integration. That you can remember. So here 1 by d square I can write double integration of this. So it will be e to the power 2x into double integral of 8x square into sine 2x dx. Okay, so if I do this single integration, understood? If I do this single integration, or you can say that this is dx into dx 2 times, na? So if here you do this single integration, so this is again a byproduct method. This term 8 will come out. 8 will come out. Don't worry about 8. So just concentrate on this. So this term will work as suppose u, and this term will work as v. So these are two functions of x. So by applying the Livolli's formula, what is that? If integral of u into v is there, so then u as such integral of v minus u dash double integral of v and plus u double dash triple integral of v. So by this way you can solve such type of integration. So here 8 e to the power 2x into integral dx. One integral will be left again. Just only single integration I am doing for this. And for this, by using this formula, first function as such into integral of second function, integral of sine 2x will be minus of cos 2x divided by 2. Understood? Minus of cos 2x divided by 2. So this is the first term. Now coming to u dash. U dash is 2x into double integral of that means again you have to integrate it. It will become sine 2x by 4. It will become minus of sine 2x by 4. And one more term will be there plus. Again you differentiate this, it will become 2 only, and triple integration of that will be plus of cos 2x by 8. So now it is complete. So again you have to do 8 e to the power 2x. It will be minus, sorry, integral is there, x square into cos 2x by 2. Minus minus will become plus, 2 to 2 cancel, it will be x sine 2x by 2. And again 2 to 2 cancel, so it will be cos 2x by 4 plus cos 2x by 4 dx. Okay, so like this. Now again you have to do it. Again you have to integrate it. Again you have to integrate it. Again you have to integrate it. So it is a little bit lengthy problem, but now again you can apply the same thing. Okay, so again apply same formula it will be. So it is little bit lengthy, so I will not waste time in that. So you got the idea. Okay, so again apply UV method in this, and this is directly solved. So then whatever the answer gets, so that will be particular integral. So solution will be y equal to complementary function plus particular integral. So then that you can put here. Understood? So this is the method. So these are lengthy problems. Such problem will not appear in the exam. They will be short only, or they will be easy only, but you have to learn the method. Note down it.
Done, sir.
Okay. Now this type of problem you can solve. There is one more type of problem comes in the exam, that is Kochi Euler. Those are solved by Kochi Euler method. So let's put the heading. Okay. Form of this equation is like this: x square d2y over dx square plus x dy by dx plus y is equal to 0. Okay, so this type of equation, how to recognize that this is Cauchy Euler equation? So you have to recognize it like this, because this is also square term, this is also square term. So if these are same, if these two are same, here also you will check, here power is 1, here also power is 1. So these are also same. If these powers of differentiation and power of this independent variable both are same, here also powers are same. Okay, the term by term they will differ, but always they will be same. This is the question thus. Okay, if they are same, then such equation are known as Cauchy Euler equation, and they will be solved by this method. Okay, you can write here powers of x and order of differential are same. So this is the recognition of them. Now in such problems, you have to do some replacement. You have to put x equal to e to the power z. This you remember, many times this question have come in the exam, net exam. Okay, so you have to remember it. In such question you have to just put x equal to e to the power z. So this implies here x into d by dx, because x square into d2 by dx square, x into d by dx, they are together. So x into d by dx, you have to put d by dz, or this d by dz can be given a name, just this is the first derivative, so d. Okay, now next is x square d2 over dx square, that will be working as d into d minus 1. This is the replacement. If there is x cube up to there, means lengthy problem is there, so x cube d cube by dx cube, that will be analogous to d into d minus 1 into d minus 2, and so on. Next, x to the power 4 d4 by dx4, that will be d into d minus 1 into d minus 2 into d minus 3. Like this it will be going on, etc. Okay, so these are the two rules you have to follow here. Means x is equal to e to the power z, and at the last when you get the solution, because my answer will be in z now, so at the last z will be, now take log of this, so ln x will be equal to z. So at the last you have to replace that, replace in final solution. In final solution, z again you have to convert into x by replacing this, otherwise you have to use this type of formula here. Note down this.
Done, sir.
Okay. Actually, suppose this is my equation number 1. So in equation now I have equation 1, I have to put all these things. So equation 1 will be transformed as that is x square d2 or dx square. So that I can write d into d minus 1. Okay. Y. And plus next thing is x dy dA by dx, that I can write dy, and plus y is equal to 0. So what will be fd here? D into d minus 1 plus d and plus 1. This will work as fd into y equal to 0. Okay. So I can further solve it. It will be d square minus d plus d plus 1 into y equal to 0. So d to d cancel. So this will be d square plus 1 into y is equal to 0. So what is fd here? Fd equal to d square plus 1. Okay. So on the right hand side, because it is 0, so it is homogeneous kind of thing. So here to get the auxiliary equation, put m square plus 1 equal to 0. So m square will be minus 1, m will be plus minus I. So alpha is 0, beta is 1. So solution will be, in place of solution will be y. Okay. Solution will be in y only, but in place of x it is z. Understood? Because we have replaced x equal to e to the power z. So in place of x it is z now. So y will be e to the power 0 into z and a cos beta x. Beta is 1, x is z, and plus b sin z. So now you can replace the value of z. So this is the final solution. Replace z equal to ln x. So then it will become, y will become, this is one only, a cos ln x plus b sin ln x. So this is your final answer. Some net problems are also there on this same method. You can do that also. Note down this.
Done, sir.
Okay. So quickly, can you solve one problem? Because ultimately you have to practice the things. I'm giving you a question. X square d2y or dx square minus 2x dy by dx and minus 4y is equal to x to the power 4. Can you solve this problem? Because here r is also there. So this method will give you only complementary function. So that you can do here also. Whole term you take equal to 0. So then it will give you complementary function. And I told you to get the particular integral. So to get particular integral, you will utilize 1 upon fd into r. R is x to the power 4, but that you have to convert into z term and then you have to apply. So can you solve it?
Sir, only in this Kochi Euler we get that complementary function.
Kochi Euler?
We get only the complementary.
Yeah. Only Kochi Euler is only for a complementary function, but particular integral is you have to apply the same method. But here also, na, what happens, because x we have converted into z, so that you have to do.
Yes, sir. That is a little confusion.
Okay.
So,
let me.
after this we do that the
Okay.
other method also.
Okay, so once I will do it, then you can practice, no problem. So here again, because this power is same, and here if you check, this power is 1, this power is sum, these are same, so it is the Kochi Euler. Okay, so what you have to do, substitute x equals to e to the power z. Okay, now tell me, because this side I want to here, so x to the power 4 will be e to the power 4z, so that will be my r actually. So that I wanted to tell. Only this difference is there, otherwise same. So x equals to e to the power z, and some more replacement you have to do. X d by dx you will replace by d, and x square d2 over dx square you have to replace d into d minus 1. So once you do it, so equation becomes d into d minus 1 minus 2d minus 4 into y is equal to e to the power 4z. That will be my equation now. Okay, now we can simplify it. It will become d square minus d minus 2d minus 4 into y is equal to e to the power 4z. Okay, so note down it first.
Yes, sir.
So here fd will be what? It will be d square minus 3d. D square minus 3d minus 4. So this is my fd. Okay. So now number 1, to find complementary function. So for that, put auxiliary equation. Auxiliary equation will be m square minus 3m minus 4 equal to 0. So how to get it? Because it is negative, 4 1 is 4 and 4 minus 1 will be 3. So m square minus 4m plus m minus 4 is equal to 0. So m common, m minus 4 minus 1 common, m minus plus 1 common, m minus 4 equal to 0. M minus 4 into m plus 1 equal to 0. So here m will be minus 1 plus 4. So your y1 will be c1 e to the power minus z. Understood? Plus c2 e to the power 4z. Okay. So here also I have to replace. Okay, in the last I will replace. Number second, particular integral will be same method you have to apply. Pi will be 1 upon fd into r. R is e to the power 4z. So 1 by fd. Fd is d square minus 3d minus 4 into e to the power 4z. So here it is e to the power ax type now, so you have to replace means d you have to replace d by a, that you have to do. So a is 4 here, so it will be 1 by d square, means 4 4 is 16 minus 3 into 4 12 and minus 4 e to the power 4 z. So but it is 0, okay, because f is 0. So what is our next step? You have to use it f dash. So in place of using this fa, we have to use here f dash 4. It will be f dash 4 because I have known that because f is 0. So here f dash a will be there. So now differentiate it with respect to d once. In that you put d equal to a or 4. Understood? Note down this. So this is a good question. So much insight it will give you. Okay. But I told you that if you are using the f dash, with that you have to multiply with x. So x is z here. If it is f double dash, you have to multiply by x square. So that also you have to remember.
Fine, sir.
Okay. So now here f dash d will be 2d minus 3. So f dash 4 will be, in place of d put 4, 8 minus 3 equal to 5. So this will be 1 by 5 into z into e to the power 4z. Simple. Okay. Now particular integral is with you, so y will be cf plus pi, and cf is what? C1 e to the power minus z plus C2 e to the power 4z and plus 1 by 5 z into e to the power 4z. Now this is my final answer. Here you have to replace z equal to ln x. Okay, so y will be C1 e to the power minus ln x plus C2 e to the power 4 into ln x plus 1 by 5 into ln x into e to the power 4 into ln x. Now how to solve this? C1 e to the power, this minus will go power of that x to the power minus 1. So it will be ln x to the power minus 1 plus C2 e to the power ln x to the power 4 plus 1 by 5 ln x into e to the power ln x to the power 4. So it will be C1 into x to the power minus 1 plus C2 x to the power 4 plus 1 by 5 ln x into x to the power 4. So this is the answer. Okay, note down this.
So
Yes.
1 by 5 into Z, that also is ln x. Yes, 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 got it. Done, sir.
Okay, one more question of NAT 2013 June I can take. Question is, solve x divided by dx plus 1 plus xy in is equal to e to the power minus x. Okay, so here they have given the boundary condition y1 is equal to 0. So this is given. So why they give the boundary condition? So with that you can find out the constant. So that is the only purpose. Otherwise answer will be in constant term. So how to solve it? First of all, what you have to do, you have to make it dy by dx. You have to make it coefficient 1 here with dy by dx. So then you will get an idea. Plus 1 by x by x y is equal to 1 by x. You are different. You are dividing by x now. So it will be x to the power minus 1, or you can write e to the power minus x by x. So this is dy by dx plus py is equal to q. This is working as p, this is working as q. So you have done this type of problem earlier. Okay. So here directly what you have to find? First you have to find integrating factor. So because this is not second order, this is first order differential equation. Okay, so in first order differential equation of the form dy by dx plus py equals to this q, integrating factor you have to find out. Integrating factor will be e to the power integral, this is 1 plus x by x into dx. So how to integrate it? So you can make it e to the power integral 1 by x and plus 1 dx. Now integrate it, e to the power 1 by x is ln x and plus integration of 1 is x. Okay, so now e to the power, if a plus b is there, so what we can write that? E to the power a into e to the power b. So same kind I am doing it. It will be e to the power ln x into e to the power x, and e to the power ln x will give me e and ln will go off. It will be x, e to the power x. So this is the integrating factor here. Hence, solution will be y into integrating factor equal to integral of q into integrating factor dx plus c. So by this you can find out. Okay, note down this.
Done, sir.
Okay, so y into integrating factor is x into e to the power x. Now you will see here q is what? E to the power minus x by x into integrating factor is what? X into e to the power x. See, in the exam they give you such problem that everything will be finished, only it will become easy only. Okay, so here e to the power x into e to the power x, it will be 1, and x to x also cut, so it is integral 1 only. So integral dx plus c, this is x plus c. Okay, so answer is y into x into e to the power x is equal to x plus c. So this is the answer, but here they have given the boundary condition so that you can find out the value of c. At what is boundary condition? Y1 is equal to 0. At x equal to 1, y is equal to 0. So put x equal to 1. This implies put x equal to 1, y will be 0. So 0 is equal to 1 plus c. This implies c is equal to minus 1. Hence, y into x e to the power x will be equal to x minus 1. Okay. So now you can find out directly value of y. So y will be x minus 1 by x e to the power minus x. So this is the final answer. Okay. So these are the all type of variety we have solved for the differential equations. First order, second order, both are finished.